Welcome. Hi, this is Wykid and Arthur. We're doing our third office session, office hours, and this time we've got some exciting folks, experts, practitioners in various fields to kind of talk about what they're doing. We're going to talk about recent developments. So welcome. Let's dive into it. Let's go through a quick round of intros. Um, George, you want to start?
Sure. Thanks for organizing this. I'm an entrepreneur and an investor,
I
and
think George got cut off a
like
little
to
bit.
talk
Maybe we'll
about
start from Krista.
AI and applications for artificial general intelligence and so on. So again, thanks for inviting me.
Great. Christoph, you want to go next?
Yeah, sure. I'm like something like evolutionary AI guy, so I basically use happening these days because it's the most modern concept, and I see myself something like when it comes to comparing machine learning with the stuff that I'm doing, I think I'm more like the practical guy that tries to scale it up, or mostly something like the engineering perspective also behind all of AI stuff.
That's excellent. Awesome.
Yes, and my name is Rhett Drugi, and I'm a dermatologist. And we've been doing automated whole body scanning for the last 17 years. Early on, I started telemedicine work with the Veterans Administration, trying to deliver healthcare solutions to them. And we set up a national network for what's called store and forward telemedicine. So we currently have about um, 40,000 scans of people which have about 65 images, and we're tracking. We found the world's smallest melanomas, and we're able to just do this through tracking. But now we do this with technicians and animation using a flicker type technique. But what we like to do is make this into kind of a automatic tracking process with detection. So we draw down our data as it is to small spots.
No, that's very interesting. Uh, Thanks so much for the for all everyone's introductions. Yeah, we have got a few topics. I think we've got some really meaty stuff we can go into. Maybe a quick one to start. I know Arthur has been itching to kind of talk a little bit about this. Uh, I thought it was as seminal as the AI beating the Go players is the Libratus AI poker bot winning by a wide margin and statistical significance. Arthur, do you want to kind of chime in a little bit and talk about what was so significant there?
Right. I guess so. In the case of vibratos, I think. Well, I'm actually not in that particular field, not a specialist on that thing. So what I know is really from some reading. I think there are few things that I think there are two things which is interesting. The first one is they were able to come up with a new
No, that's great. That's awesome. Yeah, I encourage everyone to go read how much they win the professional human players by. It is quite a significant amount. And it's also very interesting how they set up, how they design the experiment such that it actually X's out basically stream lucky cards. So it's actually a very smart way to set it up. Uh, Next thing, love George, love to you've written a bunch of thoughtful articles on deep learning, and you came from software side. Love to hear a little bit about you also came from the security side. Love to hear a little bit about your thoughts on deep learning, and if you get a chance, love to hear also your thoughts on deep learning in security. If you have any thoughts there, so fire away.
Want to understand your tolerance level George, for false positives. You've written. I think that's fairly obvious. A bunch of thoughtful articles not necessarily deep learning. Talked about clearly. You can generate a probability through some form of an artificial neural network, but what's the sensitivity around the conclusions that come from that? What is the tolerance level for errors? Is the probability something that has to be extremely high in order for us to make use of that information?
Hey George, sorry, it looks like you're getting cut out by Wi-Fi. All right, it looks like we lost George for a second.
Actually, I got a question to him afterwards about that, because that's actually where my AI development stuff started. My first project was something like trying to put the Metasploit database. I don't know, do you know Metasploit? It's something like a framework where you have dozens or hundreds of different exploits combined with US shares and stuff like that. So something like a remote exploitation or penetration testing toolkit. And everything there is parameterized, so you have a huge search space of hyperparameters, if you want to call it like that. And that's actually where I started getting into evolutionary eyes to solve that or to combine those more efficiently. So it would be extremely interesting to see how he actually used artificial neural networks back then for his computer security stuff. Or I think he told more about detection part and not generation part.
That's right. I think George is actually reconnecting. And wow, Kid is probably fixing the audio at the same time. Well, I do feel that George's idea is very interesting, and in the space. Oh, hey, George, how are you? You're back.
Sorry about that.
Oh, no worries. We were just talking about your idea. It's very interesting, and in fact, Christoph, you have a comment right there. Can you just bring it up again very quickly so that George can hear that as well?
My question was more if you were like on the recognizing part or like the threat prevention part, or if you were like using generational methods for creating exploits. So because my side from the evolutionary AI side is more like the generation part. So my first project back then was to create an intelligent botnet that would combine like exploits from exploit database or from metasploit database. So because it's a high-dimensional mega amount of parameters, but they are freely combinable if you know how to treat them. So that's the and if you can sort it how to treat them or how to combine them, mostly with reinforcement learning. My question was more like what kind of artificial neural network were you creating back then in the computer security sector, and what were you doing with that? If you were on the detection side or the prevention side or the generation of information side or something.
Yes, I guess the question is what kind of artificial neural network that you have been using, George? Can you tell us more?
Sure. I've used pretty vanilla multi-layer neural networks for text classification, and I published that code on Medium a couple weeks ago. And I very much like to work with these things in a no black box fashion, where all the code is there and looked at as simply as possible. I think that's a very important thing that others are following. Andrew Trask would be a great example of someone who I think is contributing significantly in that way. I've been playing around with RNNs and looking at sequencing. A lot of my work is in what I call message app auto response. I don't like the term chatbot because it implies that it's a very robotic response. But and I'm still struggling to see practical applications of RNNs and LSTMs in chatbot applications. And I recognize that's a controversial statement because people think that they're very well suited for this. But again, where the tolerance level is relatively low for gibberish, I don't think they're well suited at all. And that's a whole discussion in of itself. So I like to use artificial neural networks for very specific tasks. For example, classifying sentences to intents, which is a relatively straightforward thing. It's incredibly naive, of course. So I wouldn't say that it's a very sophisticated use, but it's very enjoyable to look at every line of code and part of a community of exploring the details of how these things work and how they don't work. And especially in the NLP community, there's a lot of confusion around computers understanding language and the reality that they don't understand it at all. And I think, again, it's interesting to find very, very useful applications while at the same time being part of a group that is shedding light on what's going on and how things work.
I think you're doing a tremendous job, and then thank you for your posting to AIPL. We enjoy your posts a lot. A comment, quick comment here is, I think you're right that whether NLP can be so, or more specifically, whether what we call chatbot can be beneficial, can be benefited by like deep learning technology is kind of is still kind of a controversial subject because right now no one really able to generate very realistic dialogue out of a deep learning system yet, or any system for that matter. So it is still something that people have been actively researching, and so on the security front, I will also hope to see whether some kind of machine learning method. Hey George, how are you? I see you again. I will hope to see whether some kind of machine learning method can detect attack automatically, and then maybe deep learning can help to uh, you know automatically learn what kind of features uh, is kind of signifying a certain attack. So it sounds very interesting.
Yeah, on the chatbot side, we will ironically, coincidentally, have a few folks in the next few weeks in one of our office hours from the chatbot world to come talk about state of the art and sort of where deep learning applications are there. Obviously, a lot of big companies they're working on this all the way from Alexa to Google and Facebook. There are also a lot of smaller companies that are building on top of Facebook and Alexa. So I think there's actually a lot of activity there, and in some ways um, it's an interesting problem space, right? Because it's basically taking NLP to some extreme level.
Yeah, I went to the virtual agent summit in San Francisco 2 weeks ago, explicitly for the purpose of trying to understand where the state of the art was. I figure if you're a virtual agent presenting at a summit like that, you're probably representative of the state of the art. And I wrote about this on Medium. I came away with three very clear readings on it, on the industry of virtual agents in 2017. The first is everyone's built their own framework in-house, very clearly, no exceptions.
When you say their own framework, do you mean everyone, meaning the big guys like Facebook, Google, or these are smaller companies?
Yes. Alexa has its own framework, right? Lex. And all these companies that were exhibiting, big or small, had their own framework. Now, that's not surprising. The second reading is that there's a direct correlation between the narrowness of your virtual agent's objectives and the depth with the capabilities within there. So narrow wins. The X.AI is a great example of a very, very narrow virtual agent. It's only trying to do one thing. And if you're not narrow, you're basically not good.
Yeah.
The most important pattern from the conference, and probably about 15 or so presentations, is that every single one of these agents is incorporating human input into the flow, meaning that the actual work is a combination or a blending of machine and human, without exception. And that, I think, is where I think the discussion is more interesting there than it is in how intelligent these machines are and how they're going to take over the world in a few years. I think it's much more interesting to really study this blending of human and machine, how it decreases over time. Nobody's talking about that, but it is a pervasive aspect of these systems, and it has a number of consequences, which we can get into at some other discussion. So I thought messaging apps are the new paradigm shift for user interface, I believe. And if you buy that even part way, then auto response is a really, really big deal. Really big deal.
Yeah.
And if you buy some of that, then this is a very important thing to work on, and definitely worthy of attention. And I look forward to seeing what your guests say.
Yeah, no. So one of the things, as I've talked to some of them, so one of the strategy is the fact that some of these guys are saying, hey, it's really tough to get a generic Q&A bot working 100%, right? So the key is to actually have human takeovers. So now you've reduced the search space, the problem space, to one where you just need to detect whether the user who is talking to the bot is struggling, right? If it is, then you basically swap over to a human, and the human takes over without the user knowing any better. And I think that is also interesting in the sense that potentially it actually has a way to generate training data back into the framework. So over time, it would actually get better, and at some point, you actually take the training's wheels off, and there'll be no humans, and it'll be fully automated. I think the other observation people have had so far is there's a little bit of a social problem. The moment you mention it's the chatbot and it's relatively general purpose, there's a bit of a tendency for users to beat the hell out of it and to try to break it. To try to basically say, hey, you know what, I found a flaw here, and the bot actually doesn't work that well. And then people get disappointed and they don't come back and use it. So part of this is social engineering as well. And I think there's just so much activity happening there. It would be really interesting to kind of see some of those guys who are in this space, what they have to say. So switching gears a little bit, Red, would love to kind of maybe hear how you guys are thinking of applying deep learning in feature detection in melanomas.
I just noticed that there's the sixth user actually joined in with us. Do you notice?
Yes, I do. That's okay.
That's Adele McCoy, who's part of our team.
Interesting.
And I just wanted to have Gary Coventry is here introduce himself, because he was the new product developer for a company called Melasciences, which had produced an FDA-approved melanoma classifier. So I think he can speak to your question most effectively. Okay, Gary.
Hey guys, just to introduce myself here. Yeah, so I was with Melasciences for about 8 years, working on a product called Melafind, which was a multispectral imaging device, specifically trained with our classifier to make a diagnostic decision whether it was a melanoma or not. And that was done with a 75 element classifier. We trained it with about 2,000 images, and then we tested it on the remaining data of about 8,000 images of melanomas and non-melanomas. So, I'm interested in moving from that technology to what's happening today with Rhett's data set, and seeing if we really can't beat this disease on a bigger level than we did with Melafind. Melafind was, an interesting product, and it was really, pioneering in many ways. But I guess the real issue was that it wasn't that much better than doctors are themselves, and it was only good at making a decision on a lesion that had already been identified as a potential melanoma. Whereas what we're looking for now is imaging the whole body and looking to see if the patient might have a skin cancer, not just is this spot a skin cancer. So it's a bigger data set, it's a bigger path, and it needs some bigger intelligence to make sense of it.
I want to go back. I think, George, your comment was very important for us as well. One of the things that we have is we already have a manual process where we were automatically capturing the whole body with synchronous capture with 25 camera array. And then we're taking that imagery, which does overlap to about 50 or 70% of the data is mutual between cameras. And then we take that data and we align it for the users. The users actually have been putting fiducial points into the data sets to align and scale the images using human vision. That's created millions of fiducial points. And also these technicians have gone through and picked out hotspots. And then furthermore, we've taken those hotspots and created very close-up microscopic views of the skin in those hotspots. And then the doctor comes along and makes a diagnosis. And then yet again, you come in and you biopsy the ones for even stronger diagnostic accuracy of the pathologist. And this kind of multi-step process we hope to improve by enhancing the tracking, enhancing the registration of the information data over time to be able to kind of make it a more facile, more immediate and precise type of operation, but still without losing the human oversight, George, which I think is an important point to where we're going with this.
Yeah, no, that's interesting. I'm curious in your efforts so far. In terms of, I'm curious sort of your training. How you are dealing with your training data, your labeling, and how much training data you guys have found is sufficient to produce a what you define as a workable detection solution.
Well, we are pre-training.
Okay.
We haven't actually, we're working with a group out of Carnegie Mellon named Semantic MD. We've also been in touch with the Stanford group with Esteva with respect to his work in tracking. We are neophytes and we're trying to understand how to enter in this. We have a huge data set which we think is extremely useful for machine learning, because we can integrate the results of the hotspot detection and fiducial point detections that a deep learning process could generate, and then we could use the enhanced tracking to further augment the precision of our technicians. So we're hoping that we get two boosts in terms of our power. One is an automation of the change detection of these minute little specks that change. They may be sub-millimeter in size across the whole body. And then we can also provide better animation for better registration of images, so that the technicians can have a much greater view, more precise view for quality control purposes as well.
And Rhett, is this data set? Can you talk a little bit more about it? Is this a labeled data set, or these are unlabeled data?
No, they are. So our process is as such. We have patients who we deem to be at high risk for cancers of the skin enter into a scanning device, and they have an exhaustive medical record going into that, and then that information is then reviewed by a technician who picks out spots that are suspicious, and then we take and we put secondary high-resolution images to those, which generate probably about, in some, depending on the disease state, you might assume the dermatology reference there would be a very high prediction. Melanoma has about most dermatologists can provide maybe 35 or 40% accuracy of diagnosis of some of these. In some cases with other easier skin cancers with more predictive features, there can be about an 85 or 90% accuracy of prediction. So many of these images are labeled. Some of the images which are devoid of interesting hotspots are not labeled, but they have been reviewed. Does that answer your question?
Yeah, got it. And how big is the data set?
We do have how big is the data set?
Yeah.
Well, about 40,000 patients. We've been scanning people since 2000. So we actually have a 16 and a half year experience with this, and we've collected maybe 10 to 15,000 biopsies. So those have XY coordinates, and we also have about 55,000 close-up microscopic images, which are laid in with XY coordinates in the time-lapse images. So there'll be X prime, Y prime, and XY kind of collected over time. So and people are in very standardized positions. The lighting is standardized. So we think that this is a good feeder stock for a deep learning process.
And sorry, is this data is this public data? I mean, or is this proprietary to you guys?
It's proprietary to us, and we have about 5 scanners in the Northeast, one in Long Island, one in Manhattan, 2 in Connecticut, and 1 in New Hampshire. So but our Stamford location in Connecticut is our most intensive data collection site, which is where I work. Driving the process has been kind of a critical point of it. So the data was collected under an IRB, an Institutional Review Board process. We work with other data miners, so to speak, who have used some of our microscopic images to do feature extraction. You can have various features that are present, just as Gary was suggesting. He has a lot of features in his data set that he was using with the Melifine instrument. Well, we can elicit features and use them as kernels in SVM or other types of machine learning patterns to predict what we have here. And there are multiple points in which we can kind of interdict and predict the presence or absence of cancer, or the presence or absence of risk for cancer, which is another feature. We would like a kind of a global analysis of the person's, like say, cancer predictability, where in their body they might have it, and what actual type of processing they should be undergoing, what kind of screening frequency they would benefit from, and other questions like, what is the time-lapse change of microscopic imagery? So we have a very large and rich data set, including many survey forms, and our electronic health records go back about 25 years. So we do have also a lot of information on other diseases that the people have.
Got it. No, that's very helpful. That's really interesting. I think, deep learning applied to medicine and healthcare in general, I think, over the next few decades, going to be game changing, right? I think anywhere from diagnosis and treatment protocols to, just dealing with just the bureaucracy of a gigantic healthcare system. I think it'll be really interesting to kind of see how that changes in the next few years in the short term.
I'll just give you a hint as to, our outcomes are already quite amazing. We actually have identified the world's smallest melanoma ever seen and published it last August. And then our latest submission to a journal showed that 35% of the melanomas that we find are less than 3 millimeters in diameter, compared to the normal, which would be the best other study is 2.5% or less than 3 millimeters.
The smallest ones, in this case, are those generally not detectable by the human naked eye?
Rare. It would be rare for them to detect it because they actually come up as featureless, information-free, just dots, which are very subtle, and they require microscopic imaging for the doctor to actually make a clear decision. So these are normally passed over. And it's really a huge quantitative challenge. We have people with 5 or 10,000 spots that are in range for being melanoma, like 1 millimeter or larger. We found melanomas as small as 0.8 of a millimeter. So the challenge is that these can become invasive and potentially deadly as small as 1.6 millimeters diameter. So they don't wait for the doctor to find them. So the model, it turns out that screening for skin cancer has been shown to be insensitive by visual skin examination, with at least a 50% insensitivity for, let's say, 6 millimeter or larger melanomas, and about a 99% insensitivity for melanomas that are in the range where we're finding them, in the sub 3 millimeter range.
Wow.
But this is the most common reason that people go to the dermatologist for, which predicts melanoma, is a new or changed spot. So we can really hook into this information bit as to whether or not this is new or changed, and make a dramatic detection difference in sensitivity.
Now, this is awesome. We've got a bunch of questions, a few questions coming in from the live stream. We'll hold them off near the end. But switching gears a little bit, that's super fascinating. We'll come back to it. Christoph, would it be interesting to kind of hear about your work that you've done in genetic and evolutionary algorithms? I'm not deep in it, but it's something that a lot of companies, for example, some of the earliest algorithms that Google had written were genetic. So would love to kind of hear, how you are combining that with any of your neural network applications and what you're finding.
Okay. I think to explain what evolution can do or genetic programming can do, first I gotta tell you that that's the so-called random search space, right? Because you know that randomization always will come up with a solution, but it will directly use the definite amount of infinity when it comes to the time. And genetic programming in DNA is mostly to find better guessing values that are close to the perfect value, but they will probably never reach the perfect value because it will use an infinite amount of time. So the idea to combine evolution with backpropagation, for example, isn't that new. It's not that special. The only thing that you have to do is you have to figure out when to actually say that you have a mutation rate and want to decrease it over time. So the mutation rate is always what kills the performance of evolutionary algorithms. So when you find it on a timeline and you left and right, and you see, okay, there's a point in time where evolution won't cut it anymore. That's the step where you need to use backpropagation. And pretty much any neural network they have can be built with evolution to find random values or random weights more detailed. And if evolution doesn't cut it anymore, you can measure the behaviors. If the behaviors won't increase over the length, like say elasticity evolution cycles, you can just use backpropagation there. And the implementation would be just got something like backpropagation is active or not, as a true and false flag is active, then you can do cross-programming to get closer to perfect values. Yeah. Did I explain or answer your question? I don't know.
So why we can't see you at this? But did you?
I muted my video. Yeah. So go ahead.
No worries. On that space, I'm very curious of how things work, because I'm mostly more like a guy work on either supervised learning and unsupervised learning, but I have less knowledge about genetic algorithm or reinforcement learning. What do you think that in nowadays many people talk about using reinforcement learning, and they seem to think that it is a method that is in many cases could be better than evolution algorithm. What do you how will you comment on that? Is that the case, or is it only in certain problems that is the case?
Well, okay. The problem is like when you use or when you want to train neural networks, you gotta say, I have those networks, for example. Just talking about neural networks.
Hey, Christoph, you're cutting out a little bit. If you don't mind, maybe try reloading. I think your connection is dropping packets.
Maybe it gets better when
Yeah.
mute my video as well.
Yes, that's actually better.
Okay.
Thank you.
Okay, nice. Yeah, so the question was more about, okay, when we talk about neural networks, you have to decrease the parameters that you actually want to learn, or that you want to vectorize, or whatever you want to call it. The importance is that evolution is a linear algorithm. So when you have like 10 parameters compared to 20 parameters will exactly need only the double amount of the time, and not grow exponentially. And when you use reinforcement learning in general, and only reinforcement learning without evolution, you always have exponentially more complex search space. So that means if you have 10 parameters compared to 20 parameters, you at least need more than 4 times the time. Even if it's like the super hyper optimized RNN or QNN or whatnot. And the advantage of evolution is that evolution is only analyzing behaviors. So that means it doesn't give a single fuck about if it's the correct answer or not. It only tries to figure out if it's the more perfect answer compared to what it already knows.
That's right.
So that means you can use systems where you have thousands or hundred thousands of parameters and even compute it on a single machine without problems. Just because evolution is like made for a hyperparameter environment, and that's the advantage of evolutionary AIs compared to using only plain backpropagation or plain reinforcement learning for that.
That's very interesting. Now, Christoph, a lot of the members at AIDL, they are all learners, a little bit like me, and so how would you say, and how would you tell us on how to approach the whole genetic algorithm space? What would be, let's say 2 to 3 topmost resources you will recommend us to go into if we are interested in doing evolution programming or genetic algorithm? I know they are different, but but generally they could be discussed together a lot of times. So I wonder how you think about that.
Okay, when it comes to like the Coursera course for machine learning, for example, that's of course like a standard topic. Everybody should know that already. But those are like only the basics about neural networks and how to train them properly. When you want to figure out how evolution works and stuff like that, or how AIs in general were solved back then, it's important to know where we came from and what is the current suggested solution for that. So in order to understand more advanced concepts like NEAT, you have to figure out why there was a Bayesian network approach back then, why they tried to use evolution to breed neural networks, and what came after those feed-forward neural networks and stuff like that. So I always recommend the AI course, I think, of Berkeley, the CS188, and that's like I think from my personal taste, the most practical AI development course, because it teaches you how to, I think the game was a Pac-Man game, and you implement even the strategy finding algorithms and stuff like that. So you figure out what the problems with strategies are, you figure out what the search space problems are, and how to actually train it or how to validate stuff, even if you have only one point in time, and try to come up with the best suggestion, which isn't the perfect solution, of course, but the best suggestion for that specific moment.
That's very interesting, and that is kind of very different from the standard advice I saw on machine learning these days. Usually they would just go with engineers, and that would be the first class. But apparently you would suggest a more AI-ish type of class in the first place, and I think that's a very interesting recommendation.
The difference of the CS188 course is more that it's more a practical type of course. So you actually, the whole course is about building that Pac-Man game. You figure out what the problems are and you implement them yourselves. And they have demo codes all over the place, and everything is explained step by step, even online. And that's the great part about that, because it's more a practical course that doesn't teach you the theory without implementing it. And most people always have problems implementing the theory theory in practice. So when I look at the courses that I had here in the University of Mannheim, for example, I mean, they have the machine learning for advanced guys, and after the class, only like 5% implement neural networks properly in their language of choice. And that's like, what the fuck is going on? You need to know how vector propagation works, but you also need to know how practical application is and how to implement them, and what the typical bugs are that occur then, in order to come up with like better things.
Right. I think one last question I have is, what is, in your experience, what is the, say, top three applications that you work with that you find that are all these stuff such as evolution programming or genetic programming, you find that is a killer use case for this technology? Which three you would say to us? You would tell us? Applications.
Well, applications are pretty much endless. Well, if you have no, as I said before, evolution and evolutionary AIs don't have a limitation on it when it comes to hyperparameters. So if you have a huge parameter space, you're pretty much not limited. And the cool thing is that you can automate like workflows, which kind of parameter or which kind of switch does like put on the light when the thermostat is on or something like that. So you can combine it pretty much freely. What I'm currently doing, for example, is I'm teaching an AI how to program ADB robots. So I have hundreds of thousands of minimalized robot programs out there, and they are parameterized. So that means every method has a parameter, and the parameter says, hey, move from the left to the right, or combine this action with the other action. And this stacking together the programs, for example, or stacking together the variables and the communications in between is totally being able to be solved with Hypertext, for example. And that are some like of the practical applications. Like evolutionary AIs are really strong when it comes to combining different parameters. And if you think in parameters, then you can pretty much implement everything with evolutionary AIs.
That's very, very interesting. Very, very.
The thinking in parameters is really important. If you think in numerics or like values, then you won't get the idea what evolutionary AI is about. Evolutionary AI is only about combining parameters and figuring out what kind of parameters together come up with what kind of solutions.
Very interesting. Very, very. Kid, I'm done with asking questions. Sorry for so many questions.
So it looks like we have a comment from Keith R. Miller in the YouTube chat that so he had mentioned that there's a great package for genetic algorithm in R. That's actually interesting to me. So we, given the fact that we've got 10 more minutes, any before we switch to Q&A, quite a few of the questions have been submitted. Any other topics that hot topics you guys want to talk about that's kind of near and dear to your hearts?
I am curious about George's interview with Monica Anderson, and in general the state of AGI, because that's another topic that I know that there can be very deep discussions about it, but I just personally don't know too much about it, and as you know, a lot of times people just talk about, well, we integrate several advanced system together and we call it AGI. So is there more than that, or how much of these discussions are really valid? And that kind of echo back to George's point, which is, well, can we actually clarify what we are trying to talk about here, especially when we talk about AGI? So I wonder how you guys think about the whole thing. Probably if George is George here at this point?
He just I think he got cut off a bit, but it's coming back. There we go.
All right, come back. So George, if you can chime in on that topic, I would be very interested in your view.
Yeah, I think AGI is something that deserves a lot of attention, and actually receives very little, right? And the interview with Monica Anderson was a distillation of an enormous back and forth over several months. between myself and her as an AGI scientist. And I became convinced that some of the key concepts that she was putting forward, like the dual process theory, which of course is taken from Kahneman, and the idea of using soft science, fallible soft science in an AGI system, I became convinced that these are topics worth exploring. What we're talking about here is a fundamental and foundational acquisition of learning, adaptive learning, at a very foundational level. She's pursuing it from a language understanding standpoint, which I think is incredibly ambitious. But this is very important work, and I'm among those who believe that big breakthroughs at the AGI level are what's needed in order to really take the next steps. We're talking about software that is able to learn adaptive knowledge in an adaptive way, in a model-free way, as she puts it. And it's an area that's almost devoid of attention. Everyone's talking about neural networks. And again, there's a lot of useful work happening there, no question. So I invite people to look at that interview and take a look at the many projects in AGI that are very small. They're very unfunded, right? But there may be a real breakthrough to come there in that front.
That sounds very interesting. I guess one of the so I only have very superficial understanding on it, but it seems like the more mainstream field of machine learning is to kind of specialize artificial intelligence in for example, I work on speech recognition a lot, and so we specialize in one single field. And on the other hand, AGI seems to say, well, why we want many technologies together in one single box. And so it seems to me that one of the deeper issue is all these modules that we talk about, like speech recognizer or lip reading, and like just one forum members was asking, well, can lip reading help on speech recognition? And in fact, synchronizing. So just getting one of these technology working seems to be very difficult. And when you think about the synchronizing these information together and fuse them together, that's what we're doing with our brain, but it doesn't seem to be such an easy task in engineering side. But I agree with you. This is a very interesting space that hopefully the next few years we see more discussions about it. Yeah.
Yeah. So I think we lost Joy. Yeah. No, I agree. I agree. I think this is a right. I think we are. Neural networks seems to have at least kind of held the day for now, right? But it is ultimately one of potentially other paradigms that work well. So I think there are a lot of. I personally have been very intrigued by Jeff Hawkins' framework. Right? Jeff has been kind of working on. Jeff was the founder of Palm. Remember the Palm Pilot, and he's been kind of working on understanding of how the prefrontal cortex really works. And yeah, I think up-leveling it and really thinking through what other models could take us beyond supervised learning. What are sort of the next few steps in terms of reinforcement learning? I think it's really interesting.
One of the important questions that is full of debate is whether the real milestone ahead of us is human intelligence, or which is inherent in the pursuit of language, or whether the more practical milestone is a much simpler life form. You could argue that insects are incredibly intelligent. Some of them, like bees, stunning intelligence, right? So, and of course, many insects are.
Once again, I think there's a cutoff.
Different discussion.
Yeah. So no, I think that's right. It feels like there are various forms of intelligence. I think we're certainly trying to solve one form. We've got a couple more minutes. We have a few questions from the chat, so let's run through them quickly. One is, how could deep learning helps in chatbot development using AI/ML? George, so I think AI/ML is the artificial intelligence markup language.
Yeah.
Any comments?
I would discourage people from using AI/ML. It is brute force. It doesn't scale. I wrote about this in a Medium post entitled "The AI Label is Mostly Bullshit." I would discourage people from using it on the basis that it is pure brute force. There's no escaping that. And so there's much better ways of, for example, determining what the message's intent might be.
Yeah, interesting. Next question we have, I think it's for Rhett. Can you describe the pipeline as well for melanoma detection? I think what the audience what the user meant is, how do you go about, what are the steps in terms of determining if something is cancerous?
Okay, step number one is we usually pre-examine the patient and look for just visually easily detected skin exam based spots. But then we take patients who are high risk, who have 5 or more spots, let's say on an arm under the age of 40, people who have intense sun damage on the skin over age 50, or some other parameter like prior skin cancers, and then we would put them into a scanner and then see them back in 6 to 12 months, rescan, and then look for changes for that person. And then we have a technician basically flicker registered images in an animated mode so that they can then see and pick out subtle changes. And then those subtle changes are considered to be hotspots in our system. And then the doctor takes a look at those underneath with a microscopic view and the report of the hotspot changes. So you would then the doctor will predict what that is. Now, all these steps could be modified and enhanced with machine learning to maximize the effectiveness of, number one, original examination could be susceptible to predictive values from some kind of deep learning. Number two, the spot microscopic could be classified. Number three, the character of the changes over time could be classified as well. The very, and then the changes of microscopic imagery itself can also be classified. And each one of these steps has been, clarified in various studies to see how accurate they are. People have developed different algorithms to manage that type of information.
Cool. Now that's interesting.
I just wanted to go back before we left about the problem of general knowledge, artificial intelligence. In our work, we're using obviously a very large part of the body, the entire body, to see a little spot. And so the question keeps coming up over and over again, what will we do with the general physical examination beyond the visual skin examination? So there are elements in the examination which are accessible to us, like people's stature, their posture, their mood, their waist-hip ratio, other predictors of their general physical examination. So what we think of this system is as people would come in with their apps, their health app information, that will be embedded or sucked up into our scanner information. Then we will do analysis of their body from a myriad of different app perspectives, and then they'll exit with a complete examination, which will make our process more palatable to general physical examiners such as primary care doctors. There's been a great number of articles written recently about the death of physical examination, and what will replace it may be some kind of environment such as a deep learning environment where people get a whole body scan, not only for the spot detection, but also for the question of movement disorders and other elements that are accessible in that type of highly sensed environment.
Yeah, no, that's really interesting. I think we are unfortunately a few minutes over time. This has been a great discussion. I think it's been wide ranging, but I think there's some topics that touch on some of the big challenges that I think deep learning and general artificial intelligence can solve. With that, I thank everyone for taking time out to participate, and we'll have another one hopefully in the next week or two. And I will post this back into the forum.
Awesome.
Thanks, guys.
Thank you very much.
See you guys. Bye bye.